Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you'd like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. So this will be the third method of solution using multivariate transformation of the problem I posted on April 10th. It was also posted as an online exercise July 8, 2006. It's for exam P on probability. A device containing two key components fails when and only when both components fail. The lifetimes T1 and T2 of these components are independent with common density function f of t equal to e to the minus t for t greater than 0. The cost x of operating the device until failure is 2t1 plus t2. Which of the following is a density function of x for x greater than 0? So we will create a bivariate transformation of t1 and t2 into x and some other random variable, and that other one I'll call y, and we need to pick a y so that it's easy to find the inverse transformation. So a transformation that would take us back from xy to t1, t2. So the problem tells us x is equal to t1 plus t2, and I'm going to say y equals t2. Then, if you solve, basically have a bivariate transformation xy equals 2t1 plus t2 and t2. So we need to solve this for t1 and for t2. Well, t2 is of course equal to y. And then how do you find t1? Well, you can see that it's equal to x minus y divided by 2. Well, okay, then t1 is x minus y divided by 2, so that the partial derivative of t1 with respect to x is 1/2, and with respect to y is negative 1/2. And t2 is equal to y, so the partial derivative of t2 with respect to x is 0, with respect to y is 1, and the determinant of that matrix of partial derivatives is 1/2. And the joint density of xy is the joint density of t1, t2 evaluated at t1 that corresponds to x and y, and t2 that corresponds to x and y, times the absolute value of that determinant, which is of course 1/2. So what do we get? Well, the density of t1 is e to the minus t1, but t1 is equal to 1/2 of x minus y. So we have e to the minus 1/2 x minus y, minus coming from e to the minus t1. And then t2 is equal to y, so this evaluated at t2 that corresponds to x and y is just e to the minus y. So this is really a way of writing this in terms of x and y. t1 and t2 are both expressed in terms of x and y, and times 1/2, which is the absolute value of that determinant. And that's overall equal to 1/2 e to the minus 1/2 x plus y. For t1 equal to x minus y over 2, and t1 has to be positive. So x minus y over 2 has to be positive. So x minus y has to be positive, which means that x is more than y. And t2 equal to y, that also has to be positive. So the conditions on x and y are not as simple as t1 was greater than 0, t2 greater than 0, that was it. Here we must have 0 less than y less than x. And from this we can now calculate the marginal density of x from the joint density. The marginal density of x is the integral over all possible values of y of f sub xy of xy dy. And what are the possible values of y for a fixed value of x? Well, they are y runs from 0 to x. So this is the integral from 0 to x of 1/2 e to the minus 1/2 x plus y dy. And if we calculate the integral of this, then it's going to be just minus e to the minus 1/2 x plus y. We calculating this with respect to y. I'll treat this as a function of y. So just take a look. If you take the derivative of minus e to the minus 1/2 x plus y with respect to y, what do you get? Well, you get negative 1/2 from the exponent needs to be put in front because it's multiplied by y, and negative 1/2 times this minus sign on negative 1 in front will give us 1/2. And the function is exponential, so it will remain e to the minus 1/2 x plus y, which is exactly what we integrate. And this is evaluated from 0 to x. And the value at y equal to x is, well, minus e to the minus 1/2 x plus x. So 2x times 1/2, well, that's just minus x. So the first expression is minus e to the minus x. And the second expression at y equal to 0, that's just, and we're subtracting it. So minus e to the minus 1/2 x. A minus gives us plus. And therefore this we can write as e to the minus 1/2 x minus e to the minus x for x greater than 0, which is answer A. Now look at that. We did it 3 ways and we got the same answer. Very, very reassuring. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries, is reproduced with permission. The solution is mine. Good luck in your studies and good luck on the test.